Are you a Fusion 360 user, or have you always wanted to get started? Do you want to learn all about the tools within the sketching environment in Fusion 360? How to use parameters and learn all about 3D sketching? And see a few examples of how you can use sketching to drive complex 3D geometries. If so, this LinkedIn learning course is for you. Fusion 360 Sketching Fundamentals. My name is Aram and I have been professionally using design tools to help me make production parts for over 15 years. I have been using Fusion professionally for the last 8. So let's get sketching. Really quickly, I want to talk about versioning and timelines inside of Fusion. So in Fusion here, at the bottom of our menu, we have a timeline. Now you can see here that I just have a simple sketch. If you right click and you can go edit, and that will take you into the sketch itself. If you do any other action after that sketch, or to do anything with the sketch, it will be added along the timeline right here chronologically. Now, just to jump over to another project we're going to be doing in this course, you'll see that there's a sketch and then there is modeling moves. These are all extrudes. So you have extrudes that are happening afterwards. So if you want to go back to the sketch, you could just simply right click, edit sketch. Now, something else that you'll notice on the tops here, you'll have these V1s. So these are all version 1s. Now, if I open up my data panel, you'll see that I have many. These are all of the assets for this project. And you'll see a lot of these have version 2. So what this is versions of each. So these are the initial creation, version 1, and then this is version 2. So this is the one that was saved. Every time you hit save, it creates a new version. Now, you can also put notes and comments on the versions. You can also promote. If you right click on these assets, you can actually promote these to a newer version so that you can open the first version, the second version, the third, fourth, or fifth. So just to keep in mind about versioning and timelines in Fusion 360. Throughout this course, I have assets created for each of the videos. Now, most of the assets are end of state assets. So they are for the finished version of that video. Now, you can come over here in Fusion 360 and I have my data panel open and I have all of the assets for each of the videos here. Now, if you open one of these, you'll see that this is the end of the project. But if you wanted to see how I did something, these are all done in single sketches. You can go back into the sketch itself and see the finished state of what I did with all of the parameters, dimensions, construction lines, everything I did is there. So you can see how it was created and you can update and change it if you'd like. Now, there's a couple videos that have a start file. So in chapter 2, video 3, there's a start and a final. The start means I give you a starting point of where you can start with the model if you're going to go along with me. And then I also gave you the finished one of the part that I was finished with in Fusion. So these are all of it. Now, the only thing that's different is in the final section for chapter 9, I have all of these as examples of things that were created, and each of those are end of state only, and I give you an overview of how to do the whole process. So you have all of the information there, so if you want to create something or build something new, they're there for you. So here we're in a brand new design and we have only the origin that exists here in the center. Now, if you see this origin, you can see that there is 3 planes that are selectable. Now, these planes can all have sketches built inside of them. So I could select one of these planes that I could build my sketch on. But now you could also select part of a geometry. So why don't we come up here to the top left and build a box. So we'll select this bottom construction plane and we'll create a box, simply 50 by 50. And let's make it 50 tall. So just a perfect square. Now, any of these surfaces could be selected to create a sketch, but we could also create a construction plane in reference to this plane. So if we simply come up here and go offset plane, and we could select one of these surfaces and build a construction plane. Now, a sketch can be on any of these 2D surfaces. So if we select OK, now this could be selected to create a sketch. So you could see how you could very simply make some very interesting offset construction planes or create some sketches that drive a construction plane and then build another sketch. Now, we talked a little bit before about the timeline and how these things are referenced. So something to keep in mind. If we started with a box and then built a construction plane that is referenced from that box, and then we build a sketch on that construction plane, if we make a change to this box, it would drive the change to the offset plane and to the end sketch. So something to keep in mind depending on what you're trying to do with your sketch. If you're trying to create new geometry, if you're trying to cut something, or if you're possibly trying to just start your project. So if you're trying to start your project, it's probably a good idea to reference the origin itself. That way you have nothing that's connecting to it. So if we hide our bodies here in our construction plane, we can simply select one of these surfaces, these construction planes, to start our sketch. So let's go to the top left here and select Create Sketch and select one of these. We've now gone ahead and started our sketch and we've entered the sketching environment. Now, one of the most simple yet powerful tools in sketching in Fusion is the line tool. Now, there's two ways to get into the line tool. If we go to the top of the menu bar here, you can see that it's right here. And if you don't see it here, you can click on Create, and it's right here, the first tool, line. Now, you can also see there's an L right here. That means that that's a keyboard shortcut. So we could simply select L on the keyboard, and it would launch the line tool. Now, let's go ahead and create a line. Let's reference something here, and let's come up and give it a length of 50 and an angle of 45. Hit enter, and it created that line and at a 45-degree angle. It also created a construction line right here that it's referencing that 45 degrees from. Let's hit the L on the keyboard again, launch the line tool. We can also come down here and simply create some geometry. Now, by clicking here, it actually launches another line segment directly connected to the endpoint of the previous. So we can come here and just create a really simple pentagon. And you can see that it's kind of snapping to values and giving me constraints on different parts of the line. This line here is parallel, this line is horizontal, and this line is perpendicular. So it's giving me some basic geometry constraints right within sketching. Now we can also select a point, draw a line, end it someplace, and we can hit the check mark here, which will keep us in the line tool itself, or we can select someplace and then hit enter, and we actually leave the line tool at that point. So if we wanted to go back and use the line tool again, we'd simply hit L, and we're back in the line tool. Now let's talk about rectangles. Let's go over here to the left of our menu bar and click on Create, come down to Rectangles, and you'll see that we have three rectangles. We have a 2-point rectangle, which is also shortcut R. We have a 3-point rectangle, and we have a center rectangle. Now, the 2-point rectangle is typically by default the pinned rectangle that's on the top of your menu bar. So let's start with that one. Let's click on that. We'll come back down here into our sketch and select someplace. And we'll just drag out the mouse, and this creates a rectangle. Now this rectangle is horizontal and vertical to our axes of our sketch. So let's give it a dimension of 50 and then tab 25. Enter. And that exits the rectangle tool and gives us a dimension. Now let's come up to Create, go to Rectangles, and let's go to a 3-point rectangle. Now a 3-point rectangle basically draws a line. Now this line can be at any angle that we want. And then once we specify where we want this line and the length of the line, we can then create the height of the rectangle. Now, this is really cool because you can create these rectangles at any angle that you want. Now let's go up to create and come to rectangle and select center rectangle. Now this rectangle draws it from the center. So we can specify a point that we're interested in and we want to make a rectangle around it. So we can go up here and specify 45, tab, 20, and that would give us a rectangle. Hit enter. That will exit the rectangle tool and finish the rectangle. Now you can see what's different about this rectangle is that it's being driven from two construction lines from the center point. So this is what actually drives the rectangle to create it. Now the same rules apply. If you use the enter key when you're done with your dimensioning or your rectangle, you will automatically exit the rectangle tool. If you simply select the points and click, you'll still remain within the rectangle tool itself. Just something to keep in mind. Now let's go ahead and talk about circles. If we go over here in our menu bar, you can see that there is a circle tool, and this is the most commonly used circle tool. It is the center diameter circle, and we can see all of the other options that we have. If you go under create and go to circles, you'll see that circle tool right there. It's also shortcut C. We have a 2-point circle, a 3-point circle, a 2-tangent circle, and a 3-tangent circle. So let's start with the center diameter circle. So like its name, you specify the center and then you specify the diameter. We can either click to a point or we can specify a length. So there we have 50, and from there let's try the 2-point. Now 2-point, you basically specify the diameter. So you click on a point and you extend to another point specifying the diameter. So now this is a really handy tool if you have two line segments or two pieces of geometry that need to be connected by a circle. That's how I typically use this tool. Let's go ahead and check out the 3-point circle. So this one is really cool because you specify 2 points and then you specify the diameter, and it will always intersect those 2 points. So I use this a lot when I have two pieces of lines or two geometries that I need to connect, and I want to have some control over that radius, that diameter of that circle. So I'll have a line segment on those 2 points or some sort of geometry, and then this is kind of like the connector, and I kind of get a feel for what I want. Really handy tool. I don't use it very often, but it's very handy when you need it. Now let's go ahead and use a line tool and create just some simple line geometry so that we can use the tangent. So we're going to hit L for creating some lines, and we'll just create some lines here, and maybe one right here, and then let's do something over here. There we go. So we go to create circle and let's go to tangent. So we specify a line segment, and then we can specify the diameter that we want. Now it will make sure that the circle is always tangent to those two lines. So kind of like I was talking about with how I use the 3-point, this you can use in the very similar manner, but adjust where along those two tangents you want it. Instead of specifying a point and then adjusting the radius, you always have it tangent, and you can specify where along those lines that curve is, that radius. And then let's come over here to create. We're going to go to circle and we're going to do 3-tangent circle. So we'll specify all 3 lines. And there's only one possible option because it will be tangent on all 3 line segments. So it creates a circle. And those are all of your circle tool options. So let's go ahead and talk about arcs. If we go to our menu bar up here on the left, we can go to create and come down to arcs. And we have 3 types. We have a 3-point, a center point arc, and a tangent arc. So let's start with the 3-point. Now, this is one that I use quite often. You can simply select 2 points, and then you select the radius, and you get yourself a arc. This is probably the arc tool that I use the most. This is your center here, which is specified by this point, and those are the 2 points that you had selected previously. Now, if you go here to create and go to arcs, we can do the center point arc, which is a really cool tool. I don't use it as often, but when I need it, it's really helpful. So you can first start by selecting the center of your arc, and then you can select your radius. So whatever you want that to be. And then you can specify the angle of your arc. So let's say it's 40 degrees. And there you go. You have your center point and then your arc, and it's defined by the angle of the arc. And then we also have another tool, which is one that I actually use quite a bit. It's the tangent arc. Now, tangent arc is cool because you can specify the endpoint of any segment, and it will create an arc that is tangent to the end, and you specify the radius. So we could, for instance, do something like this, and then specify another one, and we can have it be that same center line, but alternating radiuses. So you can create some really interesting shapes very quickly using it. It's also really handy if you need to make a cutting tool. So if you, for instance, had some sort of geometry and you were going to use your sketch to be a cutting tool to cut that part, you could use this as a kind of like a fillet to give it an edge to cut that part, which is how I use it when I do constructing molds and stuff. That's a really common approach that I use. It's a very handy tool. Now let's go ahead and talk about polygons. If we scroll over here to the left side of the menu bar, click on Create, come down to Polygons. Now we have 3 types of polygons: a circumscribed polygon, an inscribed polygon, and an edge polygon. Let's start with this one. And this is the one I use most commonly. And here you can specify a polygon that's driven by 2 points. One, the distance from the center of the polygon to the center of the segment of the polygon, and the amount of sides. So for instance, if we wanted to make a 10 millimeter bolt head, we could do that here by simply going 5 millimeters, and that would give us a distance of 10 millimeters across the polygon. We could also simply change the amount of sides that we have to 4, and we can make a square, or we could come back and do 3 to make a triangle, or we can come back and do 10. So, I mean, there's all kinds of options here that we can do. Let's do 3 for this example. And you can see how we created this triangle, and from the center of the triangle to the line segment of the triangle is 5 millimeters. Now let's go ahead and use the inscribe polygon tool, and let's do a very similar shape. And here, instead of driving to the side, we're driving to the point of the polygon. So let's do this 5 millimeters, and let's also do a 3-sided triangle. So if you see this, this is quite different because the distance is being measured from the center point to the end point, and that is making the triangle significantly smaller than in this example here. Now we have one other polygon tool that we can use that's also very powerful. We can use an edge polygon tool. So now here we can specify the side of the polygon. So let's do this 5 and 0 degrees. And then here we can specify the amount of sides that it has. So if it has 3 sides, it would be our triangle, or we could do 4 sides or 5, or we can come back and do 10 sides. And all of these are being driven by the actual length itself of the polygon. So these are the 3 different types of polygon tools we have here in Fusion. Let's now go ahead and look at the ellipse tool. So we'll go over here to the left part of the menu, Create, and select Ellipse. Now this is a really cool tool because this tool is very powerful in the sense that you can drive it in many different ways. So here we can specify the width of the ellipse. So we can specify the actual width, so like let's 100 millimeters, and then we can also specify the angle. So let's say we can do 10 degrees. So I simply did that by, again, hitting the tab key so I can go between the two, and then just click right there, and then you can specify the height of the ellipse itself. So this becomes super powerful because you not only were able to adjust the angle, but the length, and then you're also able to drive the height. So let's say we want this to be 50. Hit enter, and you'll see that it creates the ellipse with the correct height, the width, and the angle. Since this entire ellipse is created with construction lines, everything here is completely drivable. So we could take this 10 degrees and change it to 15 degrees, and that would work. And we could change this to 120, and it would also update. The thing that I really like about the ellipse tool is that it allows you to change the angle. That's definable within the tool itself without having to add additional constraints to the actual tool. So it makes it really usable for all kinds of different scenarios where you need some sort of complex curve, if you want to use the entire ellipse tool itself, or you just want to try to create a arc or a part of an angle of this to use as a cutting tool or an extruding tool to create a new shape. So it's a really powerful tool. It's really easy to use, and it's very quick. Now let's go ahead and talk about splines. So if we come over here to our menu bar, go to Create, come down to Spline, and you'll see that there's two splines. You have the Fit Point spline and a Control Point spline. Now you'll see that the Fit Point spline is by default in my menu bar. I actually use both of these quite a bit, but let's start with the Fit Point spline. So the spline tools are really great at creating splines, which is basically a curved line segment. So we can create points here, and it basically creates a line that drives through those points. And what's different about all of these spline tools is that the way you control the spline is what's different. Now you see here we have all of these points that we selected, and each of them, the spline, is going through each of those points. And at each of those points, we have some controls. Now, these green lines allow us to do a couple things. They change the angle of that intersecting point, and then they also change the diameter. So if the closer you go in, the sharper the diameter, the farther you go away, the more gradual. So you can kind of have a lot of control over the spline itself. You can also take all of these points and move them. This makes it really powerful so that you can make really complex curves and you have a lot of control over the spline itself. Now, if you're trying to make a spline that is very smooth and very gradual in its transitions, this can get to be a little difficult. And that's really where the other tool comes in. So if we go to Create, go down to Spline, and do the Control Point spline, this is a great tool because it basically references off of the points that you create to create a very nice, smooth transitioning spline. So now in this spline, you see that there's only these control points that drive the spline itself. So you can see how we have these really nice gradual bends. And this is really helpful if you want to make a very smooth transition and have your inputs be a little bit more gradual. So this is both really powerful tools. They both create splines. They both control the splines in slightly different ways. Now let's go ahead and talk about the mirror tool and patterns. So let's create some really simple geometry. We can come down here and just hit R for the 2-point rectangle and just make a really simple box. And then we'll hit Escape, and then we'll hit L for a simple line, and we'll create a line right here. We come back over here to Create and come down to Mirror. Let's mirror this box, and the mirror line will be the line that we just created. So the object, if we simply double click, we can select the entire chain selection of the box. If we single click, we can click each segment of the line. Now we want to select a mirror line, and that is this line right here. And so that will create this box as a mirror. Now, something to keep in mind, because this is a parametric modeler, if you select this line and move it, it will move that mirrored side as well. Now, this symmetry is connected by these constraints right here. So if we go ahead and delete these constraints, you can go ahead and move one of these lines and it does not transfer to the other side. So just something to keep in mind when you're using the mirror tool. This also applies to patterns as well. So let's look at one of the pattern tools next. Let's go ahead and create a very simple circle. And that way we can use this to create some patterns with. Let's go over here to create and come down to circular pattern. So we want to select the object that we want to create the pattern with. So that will be the circle. And then because it's a circular pattern, we want a center point. So now for us, we'll just use the origin here as the center point. And you can see how it creates 3 circles that are equidistant around that center point. Now we can add more. So we have 6 now. And then we can also suppress any of the ones that we don't want. So if we, for some reason, didn't want, for instance, this one here and this one right here, we can simply create the geometry without those. Now, you could also do a non-full rotation and do only a partial, an angle. Now, if we do the angle, you can see here we have 180 degrees, so it created those 6 circles 180 degrees. Now, if you wanted to go the other direction, if we simply put negative 180, it would flip it to this direction. So that's super cool. Then there's also another option. We could actually change this angle to symmetric, and that would create it around the center of that circle that we had originally specified. So if we change this to 5, it's a little easier to see so that you have equal spacing on both sides. So now you can have this, and regardless if it's 180 degrees, if it's negative or positive, it would be the same thing in this case. So you have this ability here to create different types of patterns very simply. Now let's go ahead and look at that same circle, but instead of circular patterns, let's look at a rectangular pattern. Now let's again select that circle, and it will automatically pick the horizontal and vertical as your directions. So you can very easily here kind of just see how this is going to work. Now we can also change the way the distance works on how it measures the distance between these circles. We're now looking at spacing, which is the space between each circle. So from the center point of the circle to the center point of the circle. Now we could, for instance, change that to 150, or we could change it to, 200. Now these are all very easy to update. Now you could also, instead of the spacing between, you could switch it to extent, and that would basically take it to the maximum distance. So if you said, for instance, I want these circles to exist within a 600 millimeters or 800 millimeter space, that could be totally done this way. And then the nice thing is, if you said, like, for instance, I want as many circles as I can fit in 1200 millimeters, you could then simply just add additional circles until you get the desired amount, and everything would exist within that distance. Now, the other thing you can do is you can change your X and Y values separately. So you can change these to whatever values that we want. And these directions are, again, one direction, or you can do symmetric. So you have the spacing left and right, very similar to the angle tool. And like the angle tool, you can also suppress any of these circles that you don't want. Now, I'm showing you this with a very simple circular geometry. You could also do this with more complex geometry or groupings of complex geometry. So if you had, for instance, some shapes that you wanted to create in patterns, you could. So you could have 4 or 5 shapes that you're creating and then pattern all of those together. Now, something to keep in mind, this is all connected to each other. So if you create this geometry, this is right here, the pattern that's being generated for the rectangular pattern, and then the circular pattern is being generated right here. So these all are connected. So just something to keep in mind on how to use patterns and mirrors. Now let's go ahead and talk about project. Now, just as a heads up, I do have in this video a asset if you want to start with, I'm starting here with some basic geometry, which is just a cylinder and a box with a threaded hole in it so that we can use some references here. If you'd like that, it is available in the download section for this video. Now, let's go ahead and create a sketch plane so that we can build our sketch and start using the project tool. So we're going to come over here to our menu bar and select offset plane. And we're going to just look at the bottom here. We'll select this and we'll go 30 millimeters, enter. So now we have a construction plane. We're then going to come up here to the menu bar and click on create sketch. We're going to create the sketch right there. Now, once we have that, you can see that this sketch plane is offset from this body and it intersects this body here. So if we go to create and we go to project include and use the project tool, which is also shortcut P, we can select an element of geometry and project it to our surface. So for instance, we can select this top face and that would give us our counterbore hole size as well as the perimeter of our part. We could also select this body here and it would give us that cylinder diameter. We could also select just this face here or this edge, which is the fillet, or the other side, anything you really want, you could select. We could also select the entire thing as a body itself. So that would just be the entire body. We could also have the projection linked, which I'll show you what that means here in a second. So if we select this top face and hit OK, and we had it selected as linked. So if we come back and finish sketch, select this side and you do a press pull, you can see how when I update the size of this box, it updates the sketch itself. So we can go cancel and we can go back down here in our timeline, right click and go to edit sketch to go back into our sketch. It's all linked. So if you don't want it linked, you just uncheck the box. If you want it linked, you can check the box. By default, it is checked. Now, this is really powerful because you can have all kinds of reference geometry in here. So if we go here and turn off that box, if this is linked, we could then create a line here in the midpoint and bring this up and create reference geometry here that is reference to the midpoint of this line. And if we updated the size of this box, it would then change the midpoint, which would change this line. So there's a lot of powerful tools that you could use with that combination and bring in that 3D geometry into your sketch. So let's go ahead and exit the line. Let's come back over here to project and do intersect. Now, if you select this, it does something a little differently. Let's turn that box back on. So if I select this top face here, you can see that there is no projected lines that are going to happen. But yet, if I come over here, there is. So now what's happening here is it's actually looking at the geometry that is intersecting the construction plane that the sketch is built on. So this body intersects the sketch in the construction plane, and so therefore it would create that circle. And again, we can either select the face, the entire body, and link the projection. So we'll say OK. Now we can go ahead and turn these bodies off, and you can see that there is this projected line here, and then you have the same ones here. A couple other things you can look at here in the project tools. You can include 3D geometry. So if we wanted to include this face, we could do that, and that would include it here. So if you needed it for some sort of reference, or if you want to do a 3D sketch based off of that, you can. And then also you can project to a surface. So if you wanted to have a sketch that you wanted to project it back onto a 3D surface, you can absolutely do that. And that's done here. So if we had, for instance, we want this face and we want to project some sort of curve that's down here, we can. This was obviously created from that sketch, so nothing would come back over, but you can project surfaces back to 3D faces. So that can be a very useful tool if you want to have your reference sketch be driven on the geometry itself. And again, we can link this as well. So some of the tools in the project tools, and this is very powerful because it allows you to connect the 3D geometry to the 2D sketches. Now that we've gone over how to use a lot of the drawing tools in sketching, let's talk about dimensions. Now, we've seen some dimensions already when using some of our drawing tools. You saw that it automatically created dimensions and angles. Now let's kind of take a deeper dive into that. We have two basic ways that you can apply dimensions. One, through the drawing tool itself that you're using, or we can use the dimension tool to apply it after the fact. So let's do it with the first using the actual drawing tools. So let's come down here. We can hit L on the keyboard for the line tool. We can simply click somewhere for a point and then the second point, and you see that we already get this dimension tool and angle tool. So let's specify 50 millimeters for a length, and let's just simply do 45 degrees for an angle. Hit enter. Now you see that there is a distance here, that's the dimension, and we also have an angle here, that's another dimension. Now we can also apply these after the fact. So let's go back to the line tool and click on a point, and let's just click right here. And then we'll hit the check mark to get out. And then we can come up here to create in the menu bar, and we can go down to sketch dimension, or we can use a shortcut D. So let's click on that. We can specify this length, and then we can change that to 50. And we can also do this angle, and we can reference this horizontal line that we already have. And we can change that to 45. Now we have ourselves a line that is 50 millimeters in length and 45 degrees in angle. So this is one way we can do it. You can also apply this to a circle. So if you went to use the circle tool, and you can see that there's a dimension that's being applied. Now we can again apply the dimension here at 50 millimeters, or we could do it after the fact. So if we just hit C for circle and click, and then we can go D for dimension, specify the circle, and we can apply a dimension now. We can also simply just use the dimension value that's been created. If we make this circle and then hit D for dimension, click on that, and we want to keep it this dimension, we can. So this is 27.28117 millimeters. We can simply just leave it at that value if that's what we wanted. So this is completely definable. We can define lengths and angles all with dimensions. We can either create the dimensions while we're using the tools, or we can do it after the fact using the dimension tool from the menu bar or with a shortcut D. Now let's go ahead and talk about constraints. Let's make some simple geometry here so that we can start constraining the geometry, and let's see what type of constraints are automatically applied to it. Let's go in the menu bar here and scroll over to the 2-point rectangle. Select that, and let's just randomly right here select it, and let's do 40 millimeters by 30 millimeters. Hit enter, and you can see that we have our dimensions that we just talked about. We also have these icons here. Now these icons are constraints. So this is the horizontal and vertical icon. Both of these constrain these lines to be parallel to the y-axis, which is this, and the x-axis, which is this. Now you'll also notice that these lines are blue. This means that this geometry is not fully constrained, because this geometry, if we right click on it and hit move, can be moved anywhere in this plane without breaking any of these rules. So let's just move that there. And now if we go and hit D and just create some simple dimensions real quick, we can do a width here, and let's do 15. And then let's do another dimension. We'll do from this point again to here, and we'll constrain this to 30. So now we have a set distance that this box rectangle exists from the origin of the sketch. So we have 15 millimeters and 30 millimeters, which now this rectangle cannot move from this point without breaking one of these constraints. So that makes this fully constrained. Now let's go ahead and create another line and see what other kind of constraints we can automatically create. Now you see that this snapped to the middle of the line, or the midpoint, and that triangle icon right there is the midpoint icon for constraints. So let's select that, and then we come up and you can see we can create, like normal, any angle and length. But when we come all the way here to 90 degrees, you can see that it also creates a 90-degree icon right there. And that is the 90-degree or perpendicular icon. And let's select a distance of 15, hit enter. And now you can see that we both have a midpoint and perpendicular constraint applied to this line right here. Now that was all done automatically by selecting where we wanted to create the line and snapping to those locations and those constraints. If we now hit the L key to create another line, we could create a line right here, and we'll just leave it like that. And we can create another line, and you can see here that I can snap that to being parallel. Those two slash lines are the parallel icon, and that creates those two lines to be parallel. But let's say they're slightly not parallel. So they're a little bit out of whack from each other, and I want to create them parallel. I can simply click up here at the parallel tool and make this line and this line parallel to each other. Now I can also do another type of constraint where, let's say I had this line right here and I had a line and I wanted to create the two lines to be collinear to each other. So let's select this one, and now they're collinear, so they're along that same line, these two. So these are some really simple ways we could add constraints to existing geometry. And then let's just simply go through some of these constraints that we have. Horizontal and vertical, which we already talked about. Coincident, which is 2 points that are connected to each other. So if there was a gap between the two lines and you wanted to connect them together, they would be connected. And that's what that constraint would do. Tangent, which is a very powerful one, where we can create lines tangent to curves. Equal, which basically means that two things are equal to each other. Let's try that one out real quick. So we could just say this line is equal to this line. And you can see now that these are both equal length lines. And we could make that also equal to that one. So now all three of these lines are equal in length. Perpendicular, which you already talked about. Fixed and unfixed, which basically locks a piece of geometry in exactly where it is and the dimensions of it. The midpoint. Concentric, which basically says that the center point of any of the arcs lines are the same, so two circles within each other. Collinear, which we already did. Symmetry, which is very similar to the mirror tool. It basically mirrors apart, so you have symmetry applied. So the mirror tool that we used previously creates symmetry. So we use two parts with a parting line, and then that is the symmetry constraint that we're using. And then curvature, which allows you to do G2 curves between two segments. So these are all of the constraints, and we can use them in many different ways. But the thing to understand is that these icons right here are what drives the constraints. So you can add these, delete these, you can have multiple constraints on one line. These are all ways you can drive and control your sketching geometries. Just as a note, this video has an asset in it that is a start file. So if you're in 0203 start, that is the asset that you have for starting this project. And there will also be a finished file, which has the final update for this asset as well. Now that we've gone ahead and talked about both dimensions and constraints, let's talk a little bit about the editing of them. So if you come down here, you can see any of these sketches, and you've seen me update some of these before, but just to clarify, you can take any of these dimensions and simply by double clicking, you can update these values. So you could change this to, for instance, 40 millimeters, and you could also update the angles. Now, something to also kind of keep in mind is that I am working in millimeters. But if for some reason you wanted to update this and say, this dimension is to be 2 inches, you could actually do that by specifying 2, and then you can use the abbreviation of the comma, and that is for inches. You can see that it actually updates and it converts it from inches to millimeters. Now you can also go to inch and it would do the same thing. And if you hover over it, you'll see that the dimension value itself is 2 inches. So something to keep in mind for updating dimensions. And then for any of these values here that are constraints, you can simply double click on these and then delete them if you don't want the constraint anymore. And I can undo. So you can do that to any of these available constraints or functions. So if you don't want this to actually be the midpoint, simply click on it and hit delete. So that's it. It makes it very easy to be able to remove constraints or update any of your dimensions. Just to let you know, on this video, I have both a starting asset and a final asset so that you have the starting location here and also the finished asset when I'm completely done. So you have both for your reference. Now that we've gone ahead and talked about sketch dimensions and constraints and a couple ways to edit them and update them, let's see what we can do with some basic sketch and using those techniques in updating both the dimensions and constraints to drive our sketch. So if we come down here, we can see that we have this rectangle here, and that rectangle is fully constrained because it's all black. So we used a 2-point rectangle to create this, and then we referenced it to the origin of the sketch with 45 dimension, which gave it its full constraint. And then everything is essentially deriving off of here. Now, this is a really good technique to use when you're building sketches and you're going to have a lot of things referenced to a certain part of it. Make sure that that part that you're referencing is fully constrained so that it makes everything down the road a lot easier to handle. Now, one of the things that's really cool is that you can take something like this arc and constrain the radius of the arc to some of your geometry. So if we come up here and go to midpoint, and let's select the radius here, and then select this line, you can see that it took the radius of this arc and connected it to the midpoint of this line. So that means that the radius of this arc should be 60 millimeters. So let's hit D for dimension and select the line. And sure enough, it says that it's 60. So that worked. Now we have a problem. So what we did here is we over-constrained the sketch, which means we had too many constraints on that sketch. So we can't actually do that. And what's going to happen, we'll see here, is that you get a dimension with a parentheses, which is essentially a read-only dimension. You can't click on this and update it like you can something like this, where if we double-click and hit 100, you can see that this is updatable. So this would update and the value here would update. So this is just reading the value of this arc, which is very helpful, but we can't update it, and that's specified by the brackets. So now that we have that set up, we can kind of come into here and let's look at some of these circles. And we can define the radius of these circles or the diameters of these circles by simply hitting D and selecting a circle. And we have a diameter of 8.1. We can change that to, let's say, 4, and that updates. Now, let's say we want to change the rest of these circles all to 4 so that they're all the same as this one. So we can do that using constraints. So if we select each of these circles and hold Shift, and then select this one, and then hit equals, because this is the only one that's dimensioned, it will update all the rest of these to be equal to the one that's been dimensioned. So now if we simply update this value, all the other values will update. So this is a really powerful way to update a bunch of different parts of the geometry by using constraints. And what's even cooler is because this rectangle was made using the offset of this rectangle, we can simply update this offset value and everything drives. Now, that happens because this circle is linked to the endpoint here, and this circle is linked to the midpoint, and then the endpoints, the midpoints, and you get the point. So this is all fully updatable, and this works really well if you had something, let's say like a bolt pattern on some sort of bracket, and you want to be able to update it. This is a really easy and simple way to do that. Now let's go ahead and take a look at some of these circles over here. So if we wanted to make something concentric to each other so that these were both the same center points, we simply could by using the constraint and specifying our circles. And there we go, we constrained it. Now we could also make this circle tangent to this line. And we can simply do that by coming up here and selecting the tangent tool, selecting the circle and the line, and they are now tangent. You can see that by this icon. Now, because these were also concentric, these two circles move together. Now, if we come up to the line tool here and select the line tool and click on that endpoint, you can see that we can snap so that these lines are parallel to each other. And if we keep going straight up, they're both parallel and tangent. So now this line here is tangent to this circle, as well as this line being tangent to this circle. So that's just to verify that that bottom line here, this one, is actually tangent to this, so you can just visualize it. But this is some really easy way that you can create some really interesting geometries and update things using both constraints and dimensions. Now let's go ahead and talk about parameters. And parameters are a really cool feature that's inside of Fusion 360, and it allows you to define values and variables to dimensions themselves. So let's go ahead and create a really simple rectangle. Just hit R, and we'll just do it right from the origin. We'll snap it, and then let's go ahead and just use the line tool, and let's just create a line that's connected to that. And then if we come in and use D for dimension and specify a dimension here, we'll just leave everything as is. We'll leave that. Let's give this a length. And then let's also define the angle here. So I'm just letting it leave all the defaults that I created. And then let's come in here to modify and do change parameters. Now you can see here that there is a favorites, user parameters, and then the model parameters themselves. And you can see here, this is the design that I'm in. Here's my sketch. And then here are all the 4 dimensions that I just created that are here. So now each of these, dimension 1, 2, 3, and 4, the units that they're in, and then their expression and their value. So this is all of the dimensions that we just created in kind of like an Excel file type format. And this allows us to know what all our dimensions are, and we can then set up and define our own dimensions as variables and as values. So this is what parameters are and kind of gives you an idea of what they are. And then throughout this chapter, we're going to dive into how to use parameters. So now let's go ahead and set up some parameters so that we can update our sketch to be driven from some simple parameters. So let's go over here to modify, and we'll go down to change parameters, and let's go ahead and add some user parameters. So we can simply put a name here, and we can do width, and then we can give it a value of 100 and hit OK. And then let's do another one, and let's do this one height, and let's do that 50, hit OK. And then let's also do an angle, and let's just call it angle since we only have one. And we scroll down to angle, and we're going to do it in degrees, and the value here, or the expression, which is going to give us our value, will be 45, hit OK. And there you go. We have each of our expressions for each of our parameters, and the names are width, height, and angle. And now any of these are updatable. So if you just double click here, you can come in and we can change this to 150 or 125, and that will change the values. So let's go ahead and hit OK. And we can simply come into here and double click on one of these and give it a value. So if I just hit H, here's the height, enter, and then let's come here and let's specify this the width. And then let's come in here and let's specify this the height value. And then let's specify this the angle that we had defined. So you can see here now all of these are being driven by the parameter that we had specified. So these values are all updatable. You'll also notice that I'm using the same height value for here as well as here. So these would both be updated together. And you can come back and go into your parameters and change any of these values. So if we wanted this 50 to be 75, and we wanted this angle to be, let's say, 62.5, hit OK, and you can see how that's updating. And now this actually does update in real time. So you saw as soon as I hit the updated value, it literally just moves and updates everything. So this is just a really powerful way that you can drive and update your sketches. Now that we went through how to set user parameters through the dialog box, we can also set some parameters and do it through the dimension tool itself. So if we come over here and just double click on this dimension, we can specify a value so that width equals, let's say, 100. And then we can update this one here, and let's go and give this height, and that is equal to 50. And then we can come in here and actually give this the value of width. And then we can come in here and specify this as an angle, like we did before, and give it 45. And there you go. And then you can actually create geometry. So for instance, we select the endpoint here, and let's give that a value of height with an angle value, and there we go. So now this is being driven by the dimension here, and this variable here is being driven by this angle here. So if we go ahead and update the height value here to 60, it would also update here. And if we updated this dimension here to 55, that would also update. Now, the thing to note about this, it's a little different, is that if you go to your change parameters, you'll notice that these are favorites and not user parameters. So these are a little different than the parameters themselves. So let's make this a little smaller, and then let's bring it over here so you can kind of see. So what's happening here is that this dimension is driving the variable, and that is driving this here. So these are referenced to each other. So you can see that this FX icon is only happening on the ones that are not the ones that created the equal to. So if you update this here, everything changes exactly the same, and they're updated the same, but this initial one that we set is still showing not having an FX value, because this is the one that's defining the variable. So this is the setup. So a little bit different. In most cases, it works exactly the same, but just a different way of doing it. So just something to keep in mind. It's very quick to do and set up. So this is a go-to method for a lot of quick references if you want to build parameters into your sketches. Now here's an example that is a relatively complicated geometry that's being referenced from parameters. Now, this is taken as a sample from another course that I've done called Fusion 360 Modeling Techniques and Workflow, where I go through the process of using sketches and geometries to drive different types of bodies and 3D bodies in Fusion 360. So if you're interested, you can check that out. But the sketching part is very similar to what we're talking about here, where we're talking about parameters, because this is built using parameters. So if we go over here to modify and change parameters, you can see here that there are a handful of user-defined parameters, and these are all different bicycle geometries that we have. So for instance, we want a seat tube angle. That's a variable that we use all the time. So this is something that a customer may want a 73-degree seat tube angle or a 74 or some variable of that they want. So this can be defined. And then in here, I use this as an example of how we could use a existing parameter and do some simple math. So we wanted this head tube angle to be less half a degree than the seat tube angle. Now, this is just an example, but you could set this to whatever you wanted. And then chainstay lengths, top tube lengths, head tube lengths, bottom bracket drops, all of these are variables that we can update very simply and very quickly. So for instance, here, if we wanted to, let's make this a little smaller so you can see everything when it updates. But if you wanted this angle to be, let's say, 74, you can see how that all changes. And this is the 74 here, and then this is the head tube angle, which is half a degree less. So if we did this to, let's say, 73 degrees, you can see all of that updates and changes. So we can also change, like, for instance, our chainstay lengths. And let's go to a 405. And you can see how this dimension here updates. So these are all ways that you can use parameters. So if we had a custom bike that we were building for someone and we wanted to quickly update all of these because they gave us some new measurements, we could do this within, simply a couple seconds. We could update all these values and have a new sketch that is updated to all the parameters that we needed. One of the handy tools inside of sketching is the ability to import vector-based file formats. Now, one of the most common is SVG files. So you can bring in a SVG file into Fusion and actually treat it like an asset where you can update it and use that as a reference geometry inside of your sketch. So let's go ahead and show you how to do that. If you go in your menu bar here and come over to Insert, and come down to Insert SVG, then you can go ahead and pick a SVG file. So I just have one that's in my downloads. And this is my Predator Cycling logo. So this is our claw logo that we have. And you can see here that we have the actual claw, and then we have all of our borders that we use for different colors and infills and patterns and stuff. And this is editable. You can move this anywhere you want in the plane. And if you wanted to move it a little more precisely, you can do that here by simply specifying the distances. And by using the arrows, you can do it in a single direction. And then if you wanted to do a scale, you can scale it by using that. And you can also do that by using the value right here. So 1 would be no scaling, 2 would be 100% scaling. So whatever you wanted to do here for that. And then also, you have these icons that will actually flip the file. So if you wanted to flip it in any direction. Now, once that's done, it actually creates geometry. So this is lines and arcs that are completely referenceable. So if we went to our line tool and zoomed in a little bit so we can get right here on this arc, I could actually create a line that's tangent to this circle. So this is fully editable. You can grab endpoints and build geometry right off of it. So it's super handy and super useful. You can also edit the actual geometry itself. So if we hit escape, these are all locked geometry. So if we just simply click here and go to unfix, that becomes a blue line, and now we can edit this. So if we wanted to simply just delete this one line, we could. We can do anything we want to the geometry and treat it like native geometry built inside of Fusion. Now let's go ahead and talk about using a DXF file to bring in geometries. So Fusion 360 can also do that, similar to SVG. So if we go down here to Insert and scroll down to DXF, this will bring in a drawing file. So this is common for something that you would do inside of AutoCAD or any other design tool where you're doing vector-based 2D drawings. So you can simply select here and grab the file format. Now, again, I'm just bringing in a Predator Cycling logo that was done. Once the file's read, you actually have quite a bit of control. So you can actually specify the units. So when you're designing in a program like this, you design this in a specific unit. So that scale is coming in to Fusion. So you can specify if you did it in inches, meters, millimeters, centimeters, or foot. And then you also have the insert mode, so you can have it treat the different layers differently. You can bring in different layers and what layers you have in your DXF file. Then you can move it in the X and Y direction. And then if you had multiple layers, this would be all visible here. Now this is a single layer, but if you had multiple layers, that would all be visible in that section. And then we can come down over here and we can see that we have, very similar to the SVG, we have a icon so we can move around our drawing, and then we can do it independently as well. So it gives you quite a bit of control. The big difference here from SVG is that this is not as editable as an SVG. So SVG, you'd be using it more for a logo or an aesthetic piece that you're bringing in, and the drawing file would be more for a precision geometry that's coming in that's from another CAD platform or another drawing tool that you needed to bring in. Or if you have a customer that was giving you some sort of asset that you needed and they had a DXF format, you could bring that in here and import that. Now, once this is brought in and converted, it is fully done native geometry inside of Fusion. So again, if we use the line tool, we can specify an endpoint, we can make things parallel, we can make things tangent, we can treat this like normal Fusion geometry. So it's a very powerful feature. And with both SVG and DXF, you can pretty much bring in any sort of vector-based file format into your sketch. Now there's another really handy tool in Fusion 360, and that is the Canvas tool. Now if you come over here in your menu bar and go over to Insert, you can come down to Canvas, or in most cases it's the default on the top here. And you can insert a image. Now you either have one that's in your cloud account, or you can bring one from your desktop. So I'm going to insert from my computer, and I have this Predator Cycling logo, just to keep the theme going. And you can select the construction plane that you want to build on. So I'm just referencing the sketch that we've already have. And you can see that this JPEG was brought in to my sketch environment. Now you can scale this very similar to the SVG. It actually has even more control over what you can do. And you'll notice that we can go in either direction. We can have independent control. We can move the entire object. We can also flip the axes. We can also scale it. We can also scale it by a single axis if we want. We also have rotational control. So we have lots of control here. And then one of the things you'll also notice is that there's actually a opacity control. Now, the reason we have this is so that we can actually use this as a reference. So for instance, if you're an industrial designer and you are designing a new part and you have hand sketches, you can bring in those sketches into Fusion as a background, and then you can literally draw your construction geometry on top of it and use this as a reference. So if we go ahead and hit OK, you'll see that we have this, and this is created in canvases, and this is that image. Now we can turn this on or turn this off, or turn all of our canvases on and off. You can have multiple ones of these. Now you can literally just draw right on top of it, so you can build your arcs and curves and really get your reference data in. And that's really helpful. The other thing you can use it for, which is something that I use it for quite often, is bringing in reference geometry. So you could actually use this to do some reverse engineering. For instance, let's say you have a bracket and that bracket has a bolt pattern on it, and the bolt pattern is a little difficult to measure, or there's a complicated pattern to it. You could actually scan it using a flatbed scanner, or take pictures from your phone and bring those images in as background and then build your geometry on top of that, so that you could then use that as your reference geometry to build out your precision geometry. And it's a really powerful, helpful tool if you're coming from it from a reverse engineering perspective, or if you're coming from it from an industrial design perspective. Canvas is an amazingly powerful tool that's built right into Fusion 360. Now let's go ahead and talk about text and how we can use text inside of the sketching environment to build text and construction geometry. So if we go over here in the menu bar and come over to Create and scroll down to Text, it's pretty straightforward. You get a basic text box. You can drag and drop it. It's your basic 2-point rectangle. And inside of here, you can add whatever text you want. For example, my name is Aram. And I could make this in different fonts. I could also change the typeface, so I could do it bold, or I can do it italicized. And then I can change the height to, let's say, 7 millimeters. I could also change the spacing to, let's say, 2. So give me a little more space. I can flip it on the horizontal or the vertical. And then I also here have some basic alignment tools. So you can kind of space this out however you want. So this is pretty powerful. You can do quite a bit of things in here, and you can create some geometry. Now, what would you use this for? One of the things you can use this inside of a sketch is maybe for simply notations to yourself within the sketch as reference of what you're going to do with the sketch or how it's to be used or some sort of scaling factor or something. So there's lots of kind of use cases in that sense. There's also the fact that you can actually use this as geometry. So you could use this to cut into a part, emboss the surface of a part for a serial number, a part number, or maybe branding of some kind. If you wanted to do some sort of pattern generation of your logo or your word, that text file across a part, you could do that using text. And also the texts are very editable because this is geometry. So let's go ahead and hit OK. And now we see that all of this construction geometry is fully editable. So we can actually angle it, we can move it, we can do all kinds of things with this. Now, let's see how we can use some basic lines and some tools to drive some of these characteristics of the sketch. So one, we could actually define these boxes. So if we did D for dimension and specified this to be a certain length, let me zoom in so it's a little easier. So I can do this, let's say 12 millimeters. And then I wanted this line to be, let's say 80. So now I have some basic dimensions here. And then I could come down here and create a line. And let's say this line is 150 millimeters long and has an angle of 10 degrees. So now I have a line right here, and I can go ahead and add some constraints. So let's make this line parallel to this line. And then let's go ahead and make a dimension and specify the distance between these two. And let's do that at 10 millimeters. And then let's go ahead and specify the distance from this point here to this point here. And we should be able to do that like this and do 25. So now we can specify how far out we want this and how high up we want this from this line. So this gives us quite a bit of control. We can also update any of these dimensions. So if we did 15 degrees, we can make that change, and that would drive this name change. If we wanted to bring this down to, let's say, 2 millimeters off the line, and we wanted to bring this to 10 millimeters, so it's closer to that point, we can control all of that. We can also control the height of this box. So if we wanted to go, let's say 5 millimeters, that would create it right here. And we get this text right along this line. So these are all things that you can do using the construction geometry created by the text box itself and the text files. So we can create some really cool text that's really drivable by our geometry, and we can later use that as a 3D asset once we're done with our sketch. Now let's go ahead and talk about the fonts themselves. Let's go ahead and create a text box, and let's just put test. Now you see here that we have many different fonts that we can choose from. Now these are all fonts that are in my computer, that are in the system fonts in Windows. So anything that's in the computer will actually load, and you can actually use inside of Fusion. Now there's a little distinction to make here. There's two main types of type fonts that there are. There is a TTF font and there's an OTF font. Now Fusion understands that TTF fonts will be supported for extruding and creating 3D assets, but OTF fonts will not. So if you have an OTF font, it will not create the 3D asset itself. So just something to keep in mind when you're using different assets and different file formats. So think about when you're doing it. So to make sure that you don't build out all of your fonts with the intent to create it into something 3D and then realize that you can't. And usually the problem is that it's an OTF font. Now, a workaround for that is you can take that font and bring it into another program, create it as an SVG file, and then bring that back into Fusion like we talked about before, using the insert SVG and then scaling that and modifying it how you want, and then bringing that into your 3D asset. So just something to keep in mind when you're using the text feature inside of Fusion. Now let's go ahead and talk about one of my favorite features inside of the text tool itself, and that is text along a path. So if you come over here to create and just create a spline for reference, and we're going to create a simple spline that just for the sake of form, and we're going to go ahead and create a text box that travels along it. So we can select here the text on a path, and then we can select the path itself, and then we can select here some text. Let's just do my name is Aram, and then we can select the font that we want. If we want to do a typeface, the height of the font, so if we went to like, let's say 8, and then we can do if it is above the line or below the line. And then we can also fit it to the path. So we can actually fit it to the entire length of the line if we want or not. And then we can also flip the direction, whichever way we want. We could center it along the line, align it to one side or the other side. Any of these features we want to do. Now, the other thing that makes this super cool is that this is all drivable. So if we actually take that spline now and edit that spline, we are actually moving that name along the spline. So this just becomes a really powerful way to modify the text. Now, remember, we can take this text now and extrude it into a 3D object. So we can use it as a cutting tool to cut into the surface of a part. We could use it with emboss and emboss it onto the surface of something that we're working on. And we can create some really cool, really interesting graphics or textures onto a part using the text features itself. So this is a really handy and powerful tool that you can use inside of Sketch. Up until now, we've been talking about sketching and in a 2D fashion, where everything was contained within the construction layer that we were inside of. Now, what if we wanted to create geometry that was outside of that plane and we wanted to come out at a different angle? Well, historically, our workflow would be to create a new construction plane and then create a new sketch and then connect those sketches together by linking them at some endpoint, or creating construction geometry that was linked. And we would use these multiple sketches to build this 3D series of sketches that were driving geometry. Now, Fusion 360 has added 3D sketching into its workflow. So this now allows us to build 3D geometry inside of the sketching environment. Now, this is a really powerful tool because now we can create these very complicated, very powerful 3D sketches to help us shape and build our parts. So here's an example of just a very simple part that I drew, and I actually did this in 3D. So if you move over, you can see that this is not a simple 2D part. This is actually a little complicated. There's a piece coming out here that's at 45 degrees, and then this is rotated on this axis and then comes up, and then we go back down and then back and connect again. And this is a fully closed sketch. So this is all linked together and it's treated like one part and it's living inside of one sketch. So this is super cool. You can design some very complicated parts, and now we can use this sketch to drive some 3D geometry that we have. We're going to be talking about in this chapter how we set up 3D sketches and the basic concepts of navigation, workflow, and later on, we're going to talk about how we can use 3D sketches like this to drive some more complicated geometries. Now let's go ahead and talk about how we turn on 3D Sketch and how we navigate within 3D Sketch. So if we scroll down here to our sketching palette and then come all the way to the bottom, you'll see this checkbox for 3D Sketch. Once you hit that, you have 3D sketching now enabled for all of your tools. So if we come up to our menu bar and select the line tool, you see now that this triad is formed. Now, this triad allows you to adjust your temporary construction plane to build your geometry, and it does it in all axes. So if I hold the shift key and I hold the center button, you can move around in 3D and you can see that each of our axes are now rotatable. Now, this is one way to navigate within 3D. You can also come up here to your view cube and hit the left mouse button and move around. So you can also orbit this way. You can also snap to any of the views that you want. So if you want a front view or this 3/4 view or angled front view, this is all movable. So once we get into our start point here that we want, we can then move around and we can move any of these axes that we want. And then once we move the axis, we can reference to that new origin, or we can create any sort of geometry within this plane. Now we can also switch planes. So you can go to any plane that you want. Once you're done with your line, you want to click it right here, you can then edit this triad anywhere you want within this plane. So, you can build geometry as complicated as you want, and then you can build this very organic, complex shapes. Now, you can see how you could get confused of where you are very quickly. So another thing that you can use to kind of re-reference yourself, once you exit the tool that I just did, you see that this sketch plane is back here. This is the original plane that you built. So if you go over here to your sketch palette and you do look at, and you hit that look at button right here, this will bring you back to your original view perpendicular to your construction plane. So you can see your construction plane head on that you started with. So this is just some basic references and how to navigate within 3D Sketch. Now let's talk about 2.5D sketching. And what I talk about 2.5D is I'm saying that I'm going to be using 3D Sketch, but I'm going to be using 3D Sketch in a more basic application where I'm going to be moving to create some basic 3D geometry, but I'm going to be doing it as a reference from my original. So something that I design all the time is bicycle frames. And so one of the setups that I use all the time is the rear triangle of a bike frame. And this is a great example of 2.5D sketching. So I'm just going to create some basic lines and we're going to create the reference geometry we need for the rear triangle of a bike. So if we use the line tool here and let's just specify this origin as our starting point. And then I'm going to come up here and I'm going to create this line and let's just say 400 millimeters. Enter. And then I'm going to create another line and I'm going to use this as a reference plane from the ground just for myself. And then I'm going to do D for dimension and I'm going to dimension this. And let's do this at 74 degrees. And then let's just zoom out and kind of resquare ourselves. And then what we're going to do is create another line. And this will be we'll refer to this as just our ground line. So this is what the axle of the wheels would be at. Just select that, that's fine. And then we'll do a distance. And we'll specify that here. And we'll do 60 millimeters. That's great. And then what we'll do is we'll do another dimension and we'll specify this. So let's do 400 for reference. So now once we have this set, I want to create, this is the axle of our rear wheel. So I want to come towards us a said length so that I have a geometry of where I want the axle end to be. So I'm going to come in, I'm going to hit escape. I'm going to use the line tool. I'm going to select this endpoint here. And then what I'm going to do is I am going to orbit over here. I'm going to select this construction plane. I'm going to snap it to the axle here. And I am going to come out 71.25. And then that gives me this. So now you see I have this line that came out here. Now let's go ahead and create another line. And we're going to reference this. I'll snap to this geometry and I'll do the same. I'll come out 71.25 and it's parallel, so that's great. And then from here, what I'll do is I'm going to come and I'm going to use another line tool again, and I'm going to take this tool and I'm going to snap it back to the origin. And then we'll scroll around and we'll do the same thing here. So now all of a sudden you can see how this is what I would call 2.5D sketching, because this is a pretty basic triangle that exists right here, and this is referencing the original sketch here. Now this is a full 3D sketch, and if I wanted to, I could add more geometry. I could snap this to here, and I could come down on this endpoint, and then I could do the other side here, and then that's an endpoint. So these are all very powerful tools because this is the rear triangle of a bike frame. So if your crank goes right here, all of these angles are adjustable and I can drive this all. So I can update these measurements, I can update these lengths, and all of this will just update. So if I went to, like, let's say 410, it makes it longer. If I drop this or higher this, so I went to 75, all of these angles change. And then these lines here can derive some 3D geometry later and be referenced from it. So this is a really good example of how you can use 2.5D sketching to build some geometry that otherwise could require 3 or 4 sketches to build some geometry like this. Now that we looked at an example of how we could use 3D sketching in what I would call a 2.5D type setup, let's look at what something I would refer to as a full 3D sketch would be. Now, this is built with no other geometry in place, and the example I'm going to give would probably be even more powerful if you had it with some other pre-done standard geometry, but this will give you a really good idea of where you can take this. So let's come over here in our menu bar and let's select the spline tool. Now, let's just select to the origin, and then let's move over here, and let's just come up, and then we can grab this construction plane here. Let's move that over. And I'm just kind of building out some geometry that I think is going to work. I keep looking back at my view cube to understand where my planes are. And then let's just snap to the end. So now this is a pretty crazy looking organic shape. And the cool thing with this is I would call this full 3D because this is not constrained to really anything. Now, this is still a fully operating spline. So what I mean by that is you can edit it like you would a normal spline. So I can come in here, I can use the move tool, and I can move any of these points anywhere I want. I can also drive anything I want. These sketches are fully drivable. And what I mean by drivable is that I can edit these however I want, meaning I can move any of these points. I can drive the spline however I see fit. Or if I come in here and I say, you know what, I don't like this point, I could actually delete these points like I would in a normal spline. So I can make a new geometry. So we can move any of our set points, and you can see how this simple move is driving so much of the geometry down the road. So this is a incredibly powerful setup so that you can drive some really complex geometry. Now, what could be really interesting is if you had some basic geometry already defined and you wanted to, let's say, update it. So you wanted to drive this organic shape and run it through the side of a part, or maybe it's going around some sort of structure. Maybe this is some sort of cable or housing of something, of electronic enclosure, and you want to drive this wire and run it through the enclosure and then, turn this into a cable. These are all things that you can do and where 3D sketching becomes super powerful. So here's an example of how I used it. This is in the spline tool. You can obviously use this in the fit spline, or you can do it in the control point spline. You can also do this with arcs. So this can get really interesting really quick, and you can make some really interesting geometry. My tip here is always to look back at your view cube. That's kind of always a good reference point so you know where you are. And remember, you can always come back and edit this. The only problem with editing is it's going to not reference the construction plane that it was built on. It's going to reference the original construction that you did. So if you notice, this is referencing the construction plane that I built originally here, and this is allowing me to move this in 3D, but it's not going to re-snap to that temporary construction plane that I built for that point. So something to keep in mind when you're creating reference geometries and parts. Now let's go ahead and drive some 3D bodies from some sketches. So let's work on all the things that we've talked about with Sketch and build upon that so we can drive some 3D geometry. So let's go ahead and use the rectangle tool. So just hit R and we'll specify the origin here, which is fine. We'll go, let's say 125 by 75 millimeters. And then we'll use the offset tool and we'll come in 10 millimeters. And then we can make a couple circles here in the midpoint. And let's go 10. And we'll do another circle over here and go 10. And then let's go ahead and do another line. And let's just make a diagonal across here. There we go. Okay, now this is just a very simple sketch. We have a box within a box using an offset, and then two lines through that, and then we have two circles that are snapped to the midpoints. So let's go ahead and finish the sketch, and let's go back to the home view. Now you can see here that we have a 2D sketch on a plane, and we are back in our modeling environment, and we can use the extrude tool here so we can take a surface and extrude it into a 3D shape. So let's click on that. Now there's a couple different ways to use the extrude tool. So the first one we're going to do is just selecting a surface. So we have this surface here, and we have this surface and this surface. Let's select everything. So we have a big rectangle, and let's go negative 25 millimeters. And you can see here that you have a couple settings. You have one here, we're going to do just the extrude, and then we selected all of our profiles. You have a start plane. This can get a little tricky here, but you have the start on the profile itself. You could also do it with an offset, and then you could also do it to an object and then an offset. So there's a couple different ways where the construction starts. And then here we have a direction. So we could do one, which is what we're doing now. We could do two side, which would allow us to do in both directions. And then we can also do symmetry. So we can add the same to each direction. And then here we have the distance. So how far we're traveling. Are we going to an object? Are we going all the way through? What are we doing? And then the distance we're traveling, and then also an angle if we want to set an angle to this. So for instance, we could set an angle here and go 10 degrees. So you get this cool little box shape. And now you could also in the operation do this as a joining into another body, a cut, select the intersection. So only the intersection between the two bodies is being the body that'll be created, a new body or a new component. So we're just going to leave it as a new body for now. And then we have that. Now, a little thing to note is that as soon as you create something from a sketch, Fusion assumes that you're not going to use the sketch again, and it just automatically hides the sketch. So in this case, we want to turn that sketch back on. And then let's do extrude again. And let's go ahead and this time grab this body. And then let us extend that. Let's go 50. And we'll hit enter. And then now that joined, because we left it, it automatically selected join, and that's one full body. Now we can come back into here and we can do extrude again. And this time let's do the thin extrude, which I actually really like. It's a very handy tool. So thin extrude allows me to select the two lines themselves. And then what I can do is I can add a wall thickness. And I can also add a side. So if I do center, and let's say we do a wall thickness of 3, and then we will do a height of the top here, and then let's do, instead of a cutting operation, let's do a join operation. So that's pretty cool. Now we got this cool reinforcement here. And then we have these two circles. So let's hit E for extrude. Let's specify these. And then let's just drag it and pull it down this way. And now that's a cutting operation. And now we were able to create this relatively simple geometry, but all from a single sketch. Now, something you can note is that once I drove that initial base piece from the sketch, it hid the sketch, but then I turned the sketch back on. Now Fusion knows that I actually want to use that sketch as a reference, so it's leaving it visible. So this is just a simple way that you could create some geometry, and obviously you could get more complex as your sketches are more complicated and you're driving more parts. So this is just an example of how we could use that sketch to drive this 3D geometry. Now let's go ahead and use a sketch, and let's go ahead and set it up so we can drive a surface instead of a solid body. So let's go ahead and use the rectangle tool again, and we'll just create a 150 by 75 rectangle. And then let's go over here and just use the fillet tool, and let's just create a fillet on either end of these. And let's go 15 millimeters. Cool. And then let's go ahead and just do a spline. And we'll just specify this over here. We'll just kind of make like a little S shape. Spline. And yeah, let's call that good. So now we have these two basic shapes. We come up here into the menu bar, and these are all to create 3D solid bodies. Let's, though, create a surface this time. So we come here to the surface tool. There are very similar tools to the solid body tools, but what we're doing here is we're creating just a surface. So if we select this line, and then we can extrude this, and we end up with this surface only, which is super cool because we can use this as a cutting tool. We could use this to create some sort of other surface and then eventually turn into a solid body, or maybe this is just some sort of reference that we need for machining something or building some sort of other geometry. So let's go ahead and turn that sketch back on because it automatically turned off. And let's go to the extrude, and we can set this here, and we can do a cool surface and maybe put a little bit of a taper on it. It wouldn't do a positive taper because it would implode on itself. So I did a negative taper so that it gets bigger as it comes out. But yeah, this is a cool surface that we have that's driven from the spline, and we can use this to drive some other types of geometry, do some cool stuff. It's just a very helpful tool. So this is a great example of that. And then we could also, let's go ahead and turn these bodies off. Let's turn this one off. And then let's do another example of something that might be interesting. You could do a revolve, and we can specify this profile here. And then for the axes, let's just specify one of these. And then let's turn that body off. And you can see how we could use that spline that we designed and then just any sort of axis that we wanted and create this very cool surface. And this is a surface only. It has no thickness. Again, we can use this as a cutting tool. We could also do it if we were going to do some composite work and we wanted just the surface. We didn't want a thickness. We're going to add that thickness in a composite tool set. This is something we could do. So there's many uses of why you want a surface, but we can use a sketch to drive both a surface as well as a solid body. Now, a tool that we talked about before that has a lot of power in sketching is the text tool and the text along a curve. Now, if you combine that with the embossing tool, you can get some really cool surfaces and some really cool serial numbering, patterning, and just design effects on a surface with text. So I'm going to give you an example of how to do that. So let's go over here to our create tools, and I'm just going to simply create a cylinder for the example for this. So let's just do a 75 millimeter diameter, and we'll go up, let's say 100. Okay, great. And then I'm going to create a sketch. And for this sake, just to make it simple, I'm going to offset a sketch from here just so that it comes out in front of the cylinder, just to make it easy to visualize. And then let's come over here and go sketch, and we'll create a sketch right here on this construction plane. And great. So let's go ahead and add some text. So we'll just make a text box right here. Let me switch to text, and then I'll make a text box. And let's just do POW 2.0. Cool. And then let's make this 10. Yeah, that looks good. We're centered. That looks good. And then let's do a simple spline, and we'll just kind of do a little curve. Nothing crazy. And then let's come over here and select the text. And this time we're going to switch it to on the path. And then here we'll just do wow, wow. And let's go maybe 6. No, it's like a 7. That's cool. And let's add a little spacing here. 2. Maybe we need a little more. Let's go 4. Or actually, you know what? Let's just do fit the path. That'll work. Okay. We'll hit OK. And then we can come in here and we can kind of adjust this however we want. This got a little too much curve there for the wow to work, but we can adjust this. And this kind of gives you an example of how much control and power you have over this. So maybe we'll go like that. This is kind of cool. And we'll just do that. So you see how we set up a curve like that, and then we hit finish sketch. And now we have these two texts that are one on a curve and one on just the plane. Now we can use the emboss tool. Now this is a really cool tool because you can take this sketch profile here and we can select a face. So we can use this one, and it will either add the emboss outside, or we can go in and flip it so it goes inside and it becomes a cutting tool. So this is super cool because you can add textures to parts, and you can also make this thickness difference. So if we just want to do like 1 millimeter, and then we can also even angle it. So you can do some really cool stuff. So you can see how you could create a couple of these text files like this and then emboss, or even do like some design work and then emboss that onto the surface of the cylinder. So you can do some really cool things. Let's turn that sketch back on, and then let us use the emboss tool, and we can do this other one up here. And then we'll do this as a surface. And sure enough, there we go. Maybe we want to turn it. and then we can have this one cut. So you can see how we can make some really interesting graphics on here pretty quickly. So yeah, that's just using the emboss tool and driven by the sketch. So you can add some really nice geometry to your 3D bodies. Now let's go ahead and build some geometry here. And we're going to build a profile of a face. And then we're going to create a spline so that we can take that profile and drive it along the path of that spline. So let's create a ellipse over here. Let's go to create ellipse and let's just specify, that's good, 98 and by about, let's do around 150. That's fine. And then let's go ahead and do an offset and we'll offset this by 5. That looks good. And then let's go ahead and create a spline and we'll do it right from the center. And then let's rotate around and we'll select this plane so that we can come straight out. And let's just come out straight at first. And then we'll kind of come up. Nice and gradual, nothing super crazy. And then let's come over here and let's rotate this just a little bit. And create another one. Let's go down here. And then let's rotate this again. And then we'll come up. And then we'll do another rotation here. And we can come down this way. Another rotation. Let's go over here. And I think that looks pretty good. So we got this spline that's kind of going down this hill. It's kind of like a roller coaster. It's going down this hill and it's working its way to the bottom here. Now we can go ahead and finish this sketch and let's use the sweep tool. So we'll click on sweep. We'll come over here and specify a profile and then we'll specify a path and the path will be the spline. And there you go. You have this very cool organic looking spline that has a tube that's running it. So this could be maybe some sort of cable housing or some sort of tunnel vacuum hose that's running inside of a unit. Or like when I said earlier that it looks kind of like a roller coaster, you could easily have created 2 circles and then actually driven this as 2 separate pipes that are coming down and created a track from it. So there's all kinds of geometry you could do. And the thing is that all of this was driven by a simple sketch, one sketch that used to drive all of this shape. So it's super powerful. Now, if you add this in conjunction with all the other tools that we've been talking about, you could create some very cool complex geometries, all being driven by sketches. A really common issue when importing SVG files is scaling them and the approach that you need to take in order to scale them properly. So let's go ahead and import our SVG file. If we just go to Insert, SVG, and we're going to import that exact same file that we did last time when I showed you how to import SVGs. Now we have this imported. Let's drag this up here. You can move this around wherever you need. You can also simply update the scaling here if you know the factor in which you need to scale it. I don't know exactly how much I want to scale this by in this scenario. So I'm going to hit OK, and I'm bringing this in. Now I need to unfix this because it's green. Green means fixed. So I'm going to select this all, and now it turned it blue. So that means it is unfixed. And then I'm going to come in here and I'm going to select this line right here because that's the line I know the dimension I want it to be, and that dimension is 73.592. So let's take that information and let us come into here and go to modify and go to sketch scale. We're going to select this entire sketch here that we imported. Now we have to specify a point from where it's going to scale. Now you can't specify a point that was already selected to scale. So what we're going to do is we're just going to select the origin here, and then now I can scale this up. But how do I know exactly how much I want to scale it by? So we know that the initial length was the 73.592. So if we say we want that line to actually be 100, we can simply just do 100, the value we want, divided by 73.592, and then hit enter. Now that scaled it up for us. And if we come back in here and grab that line, that should be now 100. Now that works great if you can move the part where you want, but what if you wanted it to be driven from one of these set points? Now there's another way you can do this. Let's go ahead and close this and finish the sketch. The other way you can do this is, now that we're outside of the sketching environment, we can create this into a solid body. So let's create this into a solid body, and I'll show you another approach that you can use depending on what you're trying to achieve within the scaling. This can be a good alternative way to do it. Get everything selected, and then we're going to do a distance of 5 millimeters. And now let's just make sure that that line is still 100. Yep, it's 100. And let's say we want to take that to 125. So we can come into modify, and we can do scale. And now we're going to scale the entire body. And in this case, we can do a set point and leave that as any geometry within the part itself. So let's say we want to do 125 divided by 100, hit enter, and voila. So it now scaled it up, and this line right here should now be 125, which it is very, very, very close to. So that is a way that you can scale SVG files, and you can control them quite a bit. And then once you have it done like this, you can use this as a cutting tool or whatever you want to use to create how you want to drive that SVG file. I'm going to go ahead and show you a cool little trick on how you can move a sketch from one reference to another reference. Let's go ahead and create a simple box. Go to create, select box, and we'll just make one right here. We'll just make a perfect square. So 100 by 100 by 100. So that's great. Now let's go ahead and create a sketch, and we'll make it on this surface here. And we'll do something pretty simple. We'll just do a circle, and we'll lock that to the center, and we'll do that 50. And then let's create a offset from that. So we'll go 5, and then let's just make a rectangle that comes out of that. And we'll do that 40 by 40. There's no real rhyme or reason to what I just made, but just so you have some nice reference geometry. And let's hit finish sketch. And now when I come back here, I realize that I made this on the wrong surface and I want to move it. Or maybe there's another body that I want to put this sketch onto. So I can come over here to the sketch itself and right click, and then come to redefine sketch plane. So if I do that, I can then select the plane to move it to. So let's select this one. Now it moved the sketch. Instead of being on the construction plane that was this box face, it's now here. And you hit OK. So now it's on the right plane, but it's in the wrong spot. So if I go back here to edit sketch, I can simply just do a move operation. I'll select all of this, and then I will go to modify, move, and I can do the point-to-point move, which is a really nice one. I like using this. So I'm going to specify point here to point here, and voila. I now have that sketch geometry that I had on the other surface, and I have it on the correct surface and moved back into the location that it needs to be into. So this is a really cool little trick if you need to move a sketch plane from one geometry to another geometry. This is a really helpful trick where you can move it quickly and seamlessly. In this video, I'm going to show you how you can create a G2 curve between a line and a spline and two splines connected to each other. So this is something that I actually use quite a bit. If you go over here and let's create some simple geometry, use the line tool, and let's just make some sort of line right here, maybe representing the edge of a part, and then we'll attach a spline to it, kind of just come off like that, and then we'll come down a little bit. And let's say this is maybe some sort of mold cavity or something. And then we'll stop, and let's say I need to add some more points, or I want to continue this spline, and I need the points I have here, but I want more points, so let's just add another spline to it. And there we go. So that's kind of our part here. And you can see here that this transition is not amazing, but if we exit out of the spline tool and come up here to the curvature tool, we can specify this line and this line, and it will create a G2 curve for this part. So it's not just creating it to be tangent, it's actually holding the curvature through the part. And it's really evident when you actually start moving this piece. So you can see here on how that curvature is actually being driven by that edge there. So this is a really handy tool to be able to have, so you can get a nice smooth transition. And now you can see that here as well. So we have these two splines and they share that one point. So if we use that same tool here, you can see how that becomes almost seamless now, because that is holding a G2 curve between those two. So now when we move a component over here, you can see how it's affecting that curvature as well. And if we use this, vice versa, we'll get the same effect. Also, if we move the endpoints here, it will move together. They'll synchronize because it's holding that curve. So we can come in like that and create this really nice constraint, and it really doesn't look anymore that we have two separate splines. It really looks like we have a really nicely done singular spline. And especially when we extrude this, you won't see any parting right there on that section. So this is a great example on how you can use constraints, and you can use the curvature tool to help control your spline better and get really nice, consistent, smooth G2 curves. I'm going to show you a really cool little trick that I actually just recently used on a project. And we're going to take some 3D geometry that we have as faces, and we're going to pull that face into a 3D sketch. And then we're going to build off of that sketch using some of the constraints and some of the tricks I've already shown you. So let's go ahead and jump right in. So I've given you this asset. So if you want to start with this project that I have right here, you can. There's a start. It's 0804 start, and then there'll be also the final, which will be the one that I finish. So just as a disclaimer. Now let's go ahead and jump right into this setup. So I'm just going to pick a sketch. It, to be honest, doesn't matter where it is. I'm just going to pick a surface here. I'm going to move around, and I'm going to come over to create. I'm going to come down to project/include. And then we're going to use this right here, include 3D geometry. Now, this is really cool. So what you can do is you can select a face, like right here, and you can see how it's created these lines. You can also create surfaces, very simple box surfaces. You can also use parts of like a globe, a sphere that we have here, and bring in some of the geometry included here. Now, super cool, right? You can bring in this geometry, but you already have this geometry. Where this becomes really powerful and useful, in the case that I had a really complicated mold line, and I needed to modify the line on the mold. So what I did is I used this tool here to bring in that 3D surface. And then I came up and I used a fit point spline, and I selected the end, and I used some 3D sketching tools, and I built some cool geometry, and I basically, build the surface that I need. And so you can build out whatever extension of that surface that you need. Now, the thing is that I need to create a better connection between these 2 points. So let me go ahead and escape. Curvature constraint. So this is what this is made for. And apply a constraint right there, and now you get that really nice transition between the two. So we can come in here and now use the move tool, and we can move this in 3D and really get this position just right so we can align everything we need for our part. So this is just a really cool use case where you could use two of the tricks that I taught you and put them on top of each other so that you can create some more complex 3D sketches. So I just want to go through a couple use cases, examples that I can give you on how we can use sketches to drive not just simple 2D things, but actually create 3D models and drive geometry with it within Fusion. So in this example, I built a very simple drawer, but it is all driven from a single sketch that is then extruded to create this entire box. So let's take a look at how I did this. So I'm going down here in my timeline, and you can see that there's one sketch and then there is 4 extrudes. So let's look at the sketch and let's see how I did it. So you go into the sketch here and it looks pretty simple. You'll notice that I built it on the mirror of the origin, and then I basically created the entire sketch on one side. So this is the one side of it that I created and then mirrored it to the other. And the reason I did that is just so that it's all updatable. So I built this, and this is the front overhang that I built, the face of the drawer. And I did this by using an offset. So this is updatable. So I can just literally come over here. When I have 15, I could do -18 and update the size of this to whatever I wanted. And then these are the sides, and then I built like a little dado, and then I actually made a little tolerance on the dado. So there's a little bit of slack. I think it's a 0.1 millimeters I have right here. And then all of these dimensions are changeable. So like if I went and said, you know what, this needs to be deeper, so I need to go to 6, I can update that to 6. And then I just need to change this down here. These are all changeable. I can update and move all of these values around. So I can move this to 6, and that would set those together. And now that I see that, I could actually simplify that. I could put a constraint on here and make these two equal, and that would make it easier. Or I could set a parameter, and I could give the parameter the values here so that these are both the same. So like dado depth, and I could actually set that. So there's different ways of approaching this, and you can totally use parameters to parameterize this entire part so it's really easily updatable if you were building drawers or some sort of production shop that was making some sort of wooden cabinets. So this is just a couple little ways to do it. And then once you have this built into geometry, you can mirror it to the other side. And then once that's done, my basic approach, let's go back in the timeline. I'll just kind of go backwards. I basically, very simple, extruded either side. I then extruded the bottom, and then I went ahead and I extruded the face. Now the sketch is over here, so that's all super simple. I mean, the only thing that I selected is when you do this, because the faces are touching, the operation, you can say join, cut, intersect, or new body. I did new body for everything, is how I did it. Now, the other thing that I went ahead and did is on the last one, I did the back, I did this one as an offset. So what I did is I offset the back of the drawer the amount of this drawer. So the depth of this extrude is the same as the offset. So that connected that here. And then that's the thickness of the material. And then again, new body. And then I just applied a nice little appearance so that it looks like wood. And that's it. You can hide the sketch. So that's a very simple way to make a cool drawer that is totally updatable. And like I said, you could totally put this with parameters to make this even more automated and simplified. Now, for this example, this is a bicycle that I designed, and this is actually designed for another course that I did for LinkedIn Learning. It's the Fusion 360 Modeling Techniques and Workflow. And the reason I'm bringing this in is because you can see here there's a sketch that's turned on. And that sketch is a 3D sketch that is driving the entire assembly of this bike. And it's all linked to that sketch. So if you update assets, it will update the entire assembly. So this is a way that you can use a 3D geometry and it references all of the bodies to the geometry. And if we update that geometry, it'll drive everything. Now, it doesn't always work seamlessly, but it works really well for an assembly like this. We might just have to go in and fix one or two little minor things if we update geometry that's a little funny. So let's kind of go in and see what's going on. So it's this number one sketch, and this is what drives the entire thing. And you'll see there's some other sketches, and these are all driving components within it. So you'll see here in the bottom of the timeline, these are broken up for the course itself into chapters. So each chapter is basically a section of the timeline. But what you want to look at is, let's look at this sketch. So let's go to Edit Sketch. Now you see that it's a relatively simple sketch. This is a 2.5D 3D sketch setup where you have the spacing for the rear stays. You also have it offset in the front here for how it comes off the bottom bracket. You'll also see that I have parameters set up. So these are all different parameters. So if I go to modify and change parameters, you can see here that these are all user-defined parameters. So for instance, if I came in here and went to, let's say we want to make a really big bike and do a 600 millimeter top tube, and then let's hit OK. You saw that this moved up, which moved the head tube, which moved the spline, moved quite a few little things. So let's see how that updates through our assembly. And it did it just fine. So it updated everything. This all stretched out, the tube stretched out, and we were able to build our assembly. So this is a really good example of how you can use 3D sketches as geometry and then reference an entire assembly to that 3D sketch. Now for this example, I went ahead and designed a kind of what looks like a turbo impeller. I am not a turbo impeller designer. I did this as an example of something you could make. This is driven from a single sketch that actually drove the shape, and then it used another sketch to make a cut plane to cut the part to give it that curved look. So let me just show you how I kind of built something like this and the approach I used to drive the geometry here. So this underlying sketch that drives this entire thing is this sketch right here, which is a very simple sketch. Let's go ahead and take a closer look at it. So this sketch is basically a circle with a spline, and that was pattern generated around this circle here, and then another circle inside of it that trimmed it, and then did a 3D line that goes right up the center. And that's essentially what builds all this geometry. Now, obviously, this is updatable, so if we actually made modifications to this, we could actually change the dimensions of our part. So that's something to keep in mind, that this is completely updatable. So once I had this constructed, it's basically a simple extrude to make a base, another extrude to make the actual impeller, the base of that, and then use the sweep tool to sweep it along that vertical line that I had created. And then this is where I was able to give it an angle so I could twist the geometry. Now, I am not, like I said, an impeller designer here, so I know that this pitch here is very specialized in impellers. I'm not saying that you could do that, but what I'm saying is that you could create this type of complex geometries using simply just sketches. And then from there, I created an offset from the bottom to just clean up that bottom area, and then created another sketch, which is right here. Now, this is a really simple, let's go ahead and turn on the main body for this. This is a really simple sketch that was created to make a surface that was going to be used to cut the impeller. So once I finished that, that was then lofted. Move that. And then that was done using a revolve. So I made a revolved surface. So I had that center line and then created a revolved surface. That was my cut tool. And then I went ahead and created the cut tool and cut it with the main body. Now it gives me all of these new bodies. And once you have this, if you don't need them, it's really simple. You can just click on these and just select them all. and you can right click. And in most cases, I would tell you to not delete them, because by deleting them, it deletes the body and it can ruin things in your timeline and your history. So a nice trick to do is just to hit remove. And this just literally, if you look down here in your timeline, it just does a remove body request for each of those. So it doesn't affect your timeline. In the timeline, it just removes the body. So just a little bit of a tip. And that's it. So within one sketch, two extrudes, a sweep, an offset, another sketch, a revolve, and a split, and a couple removes, we were able to build this geometry. So just things to keep in mind, how you can use sketching to drive some pretty cool complex bodies. Thank you for making it all the way through this course with me. I hope that this course has given you a basic understanding of 3D sketching, 2D sketching, and basic sketching fundamentals with dimensions and constraints in Fusion 360. I hope you understand that you can use sketches to drive complex 3D geometries, and it's really the essence of what drives Fusion. Sketching is something that I do every day, and I use it to create all kinds of parts. I can't wait to hear what you guys create with yours.